Hi guys, this is Amuz. In this video, I'm going to talk about the basics of Git and go through the bare essentials needed to get started. I will cover advanced topics in future videos, so let's get started. How do you set up Git in Windows? To do this, you have to go to the website called www.gitforwindows.org. Git for Windows offers a lightweight native set of tools that bring the full feature set of Git SCM to Windows. It provides you with a Git Bash, which is a bash emulation to run Git from the command line. It also provides users with a Git GUI, which is an alternative to Git Bash, where users can use the graphical user interface instead of the command line. Git for Windows also comes with shell integration, which means users can simply right-click the Explorer to access the bash or the GUI. Now, before we begin with Git, let us go through the basic workflow of Git. Your local repository consists of 3 trees maintained by Git. The first one is your working directory, which holds the actual files. The second one is the index, which acts as a staging area. And finally, the head, which points to the last commit you've made. So from your working directory, you add your files to the staging area, and once you're done, you commit them to your local Git repository. So let us see how we can do them one by one. So to create a new repository, let me create a directory called sample, get inside the directory, and now I want to initialize this directory as my local repository. To do this, you would execute git init or git initialization. As you can see from the screen, Git initialized a empty Git repository in this current folder. However, if you have a remote repository and you want to check out that remote repository into your local machine, you can do Git Clone. You can clone a repository from a local repository somewhere in your local computer. So you just have to provide the path to the repository, or if you're using a remote server like GitHub, you have to provide the URL for the repository. Let me get out. Let me say I want to clone a repository from GitHub. I already have a sample repository there. So I clone a repository from www.github.com and git demo.git. This is the remote repository. So Git clones this remote repository back into your local system, and as you can see, I have now a folder called Git demo, and if you go inside, it's basically an empty repository for now. The next, let's see how we can add files to the repository. In order to add files, you do git add and the file name. Let us create a file called readme.md and add something like a git demo. Save the changes. Now we have a new file, readme.md. It is still untracked. In order to add the file to the staging area, we do git add readme.md. Now the file is added to the staging area. To commit the file to the repository, you do git commit -m, which is a additional flag to add the commit message. Let's say added readme.md. Now the file is committed to the local repository, but it's only committed to your local head, and it is still not present in the remote repository, which is GitHub, that I cloned the repository from. If you look into GitHub, you see that the repository is still empty. So in order to push your changes to the remote repository, you have to execute a git push with the origin, that is your remote repository, and the branch name, that is master. So you're pushing your local master branch to the origins or the remote repository's master branch. You can obviously change the master to whatever branch you want to push your changes to. So this is now pushing all your local files and changes to the remote repository. However, if you have not cloned an existing repository like I did now, or as in the example before, if I had initialized my own local repository, then you want to connect your repository to a remote server, you can do something like Git Remote Add. This means you're adding to the origin, that's a remote server, whatever the URL of the server is, you are adding a remote repository. Let's say https://github.com/demo.git. So this way you are adding an existing repository to a remote server. However, because we cloned this repository from a remote server, we do not need to do this. But once you add your existing repository to a remote server, you'll be able to push your changes to your selected server. As you can see, we are working with the branch master. Branches are used to develop features isolated from each other. The master branch is the default branch when you create a repository. You can use other branches for development or for features, and then again merge them back to the master branch upon completion. So let us look into some steps of how you can create branches. To create a new branch named feature, you can execute git branch and then the name of the branch, feature1, or you can do git checkout -b and the name of the branch, feature/feature1. So what this does is it creates a new branch called feature/feature1, and it switches to that branch. Now you can see we've switched from the master branch to the feature branch. So if you want to go back to the master branch, you can do git checkout master. So now you've switched back to your master branch. If you want to delete the branch, you can do git branch -d for delete and the name of the branch. Now your local branch feature/feature1 is deleted. Remember that a branch is not available to others unless you push the branch to the remote repository. So let us create a branch again, git checkout with a new branch, features/feature1. Let us switch to that branch as well. Now let us create a file called features.txt, add some content. This is a new feature. Save the file. We have the new file features.txt. Let us add that to the staging area and commit that added feature.txt. So as you said, a branch is not available to others unless we push that into the remote repository. To do that, we do git push origin. So we want to push our branch to the origin with the branch name feature/feature1. Remember, this branch still does not exist in the remote repository. When we push this branch to the remote repository, it creates the new branch. So it's pushing the changes to the repository and it's done. If we look into the remote repository, as you see here, and refresh the page, you see that features/feature1 was added less than a minute ago. If you go into that branch, we see the readme.empty and features.txt with the value. This is a new feature just added. If you go back to the master branch, we see that features.txt is still not present there. Let us see how we can update our local repository to the newest commit from the remote branch. So in order to do that, we need to execute git pull with the name of the remote repository and the branch feature/feature1. This updates your local repository in your working directory with the files from the remote repository. It tries to fetch the file and merge those changes into your working directory. So now we have all the files that's present in the remote feature1 branch. Now, in order to merge files from a different branch to your active branch, you have to execute Git Merge. For our demo, we have a file called feature.txt, which is not present in the master branch, and you want to merge this feature branch back to the master branch. You have to go to the master branch using git checkout master. You're in the master branch, and we can see that we do not have the feature branch feature.txt file here, and you want to merge this feature branch to the master branch. To do this, you go to your active branch, execute git merge, and provide your source branch, which is features/feature1, and this merges the files from the feature branch back to your master branch. And if you look inside, you can see that feature.txt is also present in your master branch. So when you do a git pull or a git merge, in both cases Git tries to auto merge changes. Unfortunately, this is not always possible and results in conflicts. You are responsible to merge those conflicts manually by editing the file shown by Git. In later videos, I will try to show you how to do merge conflicts, but remember that you are responsible yourself to manually fix those conflicts by going inside the files which has the conflicts and manually fixing them. But once the conflicts are fixed, after you have changed your files, you need to mark your files as merged with the command git add and the file name, so that knows that the changes has been marked and merged. So after you've marked these files as merged, then you can commit the files back into the repository. You'd also maybe want to, before you do the merge, to preview what are the differences between these two files. You can do this using Git Diff, your source branch, and then your target branch. For example, I want to see the diff between master and my features branch. So you do Git Diff master and features branch. Right now you can see both are the same. There are no differences here. And this is how you update files from a remote repository and do the merge. So let's do a quick recap. We want to push the changes that we just did for master in the remote repository. To do that, we need to do git push origin master, and now this pushes the file to the remote repository. Next, so once you are done with your feature set or bug fix or whatever, and you want to release your software, and it is always recommended to create tags for software release. This is a well-known concept which also exists in SVN, Docker, or other systems. You can create a tag, let's say version 1.0, by executing git tag version 1.0, and maybe with a message release version 1.0 and enter. Now you have a tag which is basically a software release version. You can check the existing tags using git tag. So we have one tag, version 1.0. Remember that these are still in your local repository. If you want to push a tag to the remote repository, you have to do git push v 1.0 in order to git push origin 1.0. You always push something to the origin, either a branch or a tag. So now we are pushing the tag or the release version 1.0 into the remote repository, that is GitHub, which is now successfully done. All is good, but let's say we want to see the logs, what we did till now in our local repository. To do that, we execute git log in its simplest form, and you can study the repository history. For example, you can see the author, the date a commit was made, the commit hash ID, what are the commit messages, everything in the git log. For example, if you want to see commits only by a certain author, you can do git log -- author, let's say Amuz, and you can see only the logs or the commits that the provided author committed. If you want to see a very compressed log, because if you have too many logs, it will not fit in the screen, or it's very difficult to parse them or understand what is going on, you can see a very compressed log using git log --1 line. So it provides you with one-line logs. That is, added a readme file and initial features files with the commit hash as well. You can check the logs of all repositories using git log minus all, and I'm adding a -1 line so that I want to have a compressed log for all the repositories, including my local branches as well as remote repository and remote repository branches. So right now there are just 2 commits, but still we do not know what is what. So in order to decorate where these changes are coming from, we can do git log one line all with an additional flag decorate. Now we can see that the head of the current master branch, which is pointed to initial features files, is the same for our tag version 1.0, our origin master, that's our remote repositories master branch. That's also true for the origin features 1 branch, as well as our local features 1 branch. So if you only want to see files which have changed, you can do git log -name status. You can do a lot of other interesting things with the log. Let's say, for example, you want to just see an ASCII art of all the branches decorated with the names of tags and branch. You can do something like git log show me the graph, obviously compressed with 1 line, decorate them so that I know from which branch or which repository is it from, and obviously for all of them. Here you can see a basic ASCII art tree. To see more commands, you can do git log -help, which shows you all the help instructions or all the options. Yeah. Now let us clear the screen and see that we have feature.txt, readme.txt. Let me add a new file called hello.txt and add some text there. This is hello.txt file, and save that. Let me add that to the staging area, git add dot. Let me commit that, git commit -m added hello, and we can check the log using git log 1 line. So we now have a new commit with the new commit ID called added hello. But I do not want this something went wrong, and I'm sure it never happens, but if in case something went wrong and you want to replace your local changes, to do this you run the command git checkout -- the file name. What this does is this replaces the changes in your working tree with the last content in the head. Means if you have something in your staging area and you do not want that, you just move or replace that value with the last content from your head. That is your last commit. Changes that are already added to the index as well as new files will be kept. So because we have already added hello.txt to our index, it will be kept. But if instead you want to drop all your local changes and commits and fetch the latest history from the server and point to your local master branch at it, you can do something like git fetch origin. So this just fetches all the stuff from origin. It doesn't commit merge anything yet. It just gets the data, the metadata from the remote server. Now you can do git reset. I want to reset my local tree. I want to do it hard and reset using the origin / master. So now it changed my head to the last commit or the head in the master, in the remote origin master branch. All my local commits are now removed. So if you go to git log one line, sorry, missed E. So you see that our previous commit added hello is now missing, and it matches the commit status of the remote branch. And this is how you undo or replace your local changes. So that's the basic of Git. In the future videos, maybe we can go into more advanced topics like how do you rebase, how do you merge conflicts, cherry picking, and so much more. That's all for today. Thank you.